All right, good morning. This is your review for Chapter 5. This is what the quiz is. I'm going to show you exactly how I want it done. So rather than doing math and that counting and all of that actual physical stuff, I'm going to have you do something that's even better and different. And so you may be like, well, I don't want to feel sure about this. Okay, that may be the case, but this is something I think will help us pull all of the ideas together and remember them better. So what I'm going to do, we've got two options. One, you can create a video like I'm doing here, and you can write out the stuff and do it for me. Or, which will be a little bit harder because there'll be a lot of noise, or you can take out your journal. This is really what I want, but I would give you the option. You can do either one. Get out your math journal, and you're going to write out all of the key ideas and any formulas or things that are covered in the lesson. You're going to look at each example. So when I go back and I look at your Chapter 5, Lesson 1, which is 5.1, 192, so I would go like this in my notebook. If you would have to do the same thing in the video that I'm doing right here, but you can just do it in your notebook and not have to write and talk at the same time, which would be way faster. I'm just saying. Okay, lesson 5.1 is about ratio. It says key idea and ratio. Everything is about ratio in 5.1. And ratio is when you're looking at something, the first one they give us is pennies to quarters, like so. And put a little box around it like they do, pennies to quarters, and it says 5 to 8. And I could write it out. I could just say there's 5 pennies, or I could draw a picture. Depends on what you want to do. Oops, don't dot your E's. 5 pennies, and there's 8 quarters. There you go. A ratio. So the pennies to quarters, and the way it said, what is the ratio? What it says, write the ratio. This is the ratio of pennies to quarters, and the opposite would be ratio of quarters to pennies. And the reason I'm doing this is I'm showing that I understand that the first thing you say is what goes on top, quarters to pennies, and the second thing goes on the bottom. So for a quarters to pennies ratio, the quarters are on top, so it would be 8 over 5. And then if it's a really large number, they're talking about reducing it. So let's say in a class, well, let's just say like the beginning of the year we had girls to boys. If a ratio is, the next one they show is girls to boys. And let's say we just make up some number. If it was 500 to 600, don't worry about being our school at all. There's girls to boys ratio 500 to 600 in some school. Then it would be girls to boy. What's the ratio of boys to girls? The ratio of boys to girls. So we got boys on top, girls on the bottom. So it's 6 over 600 over 500, which is equal to 6 over 5. So you would reduce to the smallest number possible, if that makes sense. All right? All right, and then it shows any kind of thing you can do ratios. It also shows you how to reduce in here when you're reducing a fraction, so it's really important. Also, it starts comparing in terms of percentages. So, example number 4 on 5.1 would be really important too. Notice it has, well, let's just use this. Use percents to compare scores. So this would be something good to remember. If it's 4 over 5, it's equal to 0.8, which is equal to 80%. So you have a record here of how to take something from a fraction to a decimal to a percent. If you can't remember this step right here to this step right here, then it would be a wise choice to write it down real quick, which would be you're dividing 4 by 5. So you would do the long division here, and you would go 5 goes into 4, 0 times, and then you add your decimal. 5 goes into 40. How many times? 8. Oops, I did that in the wrong spot. 8, and then 8 times 5 is 40, and I get 0, and then look right there, I got 0.8. So that's how you got that, and then if you don't remember how to do the next one, it seems like if you looked at it, you'd figure it out. So just moving the decimal from here over 2 times to get that. And this is what you need to do on every lesson, all the way to lesson 5.6. So really, I will grade on how thorough you are on getting the concepts out of each lesson from the beginning. You don't have to do any of the problems, just the beginning part. Writing down and recording what the key idea is, or what the key concept is that is being taught, which could be, whether it's ratio or fractions, or I don't know, whatever it is, that needs to be definitely stated, and then examples of actual work that is covered. Oh, good morning. The 5th grade. This is an easy power-up. We're going to do this really quick. All right, number sense. Number A, 100 times 25. I'm just going to add 2 zeros to the 200, so it's 2,500. 7 times 25, it's 1 less than 8, so it's 1 less than 200. It's 175. 125 less than 200. And 1/2 of 40 is 20. 1/4 of 4 is 10. Oh, it's almost missed it. And 3/4 of 4 is 30. If 1/4 is 10, then 3 of them is 30, and 1/10 of 40 is 4, because it takes 10 fours to get to 40. 9 of them, that means it's 9 times 4, which is 36. And this one's fun. 7 times 7 is 49. Oh, then I add 1, which makes it 50. Then I divide by 5, which equals 10. And I divide by 5 one more time, and that equals 2. Oops, I forgot the 5. Our new concept today is the passage of time, and specific, the movement of the Earth. A day is the length of time it takes the Earth to spin around its axis once. We divide the day into 24 equal parts called hours. Each hour is divided into 60 equal parts called minutes, and each minute is divided into 60 seconds. Furthermore, besides the spinning on its axis, the Earth also moves on a long journey around the Sun. The time it takes to travel around the Sun is a year. It takes Earth about 365 1/4 days to travel around the Sun. To make the number of days in every year a whole number, we have 3 years in a row that have only 365 days in it. These are called common years. These is a term you would put in your journal. We also have years that have 366 days. That happens only once every 4, and that's called a leap year. Funny joke, if somebody was born on February 29, they would only have a birthday every 4 years. So when people have a birthday on February 29, they just celebrate on the 28th usually. All right, a year is divided into 12 months, and the month February 28, there's where we add that. They add the 29th day to make it a leap year. And this is interesting. 4 months have 30 days, and all the rest have 31 days in it. There's 7 days in a week, and we call it that. Now here's the important things here. Pay attention to this. A decade is equal to 10 years. A century is equal to 100 years. And a millennium is equal to 1,000 years. So a DEC equals 10, cent or century, cent equals 100, and mil equals 1,000. Question 1, a century is 100 years, a decade is 10 years. Since 10 tens equals 100, a century is 10 decades. And a millennium is 10 centuries. This is some review skills for a calendar. It says right here, verify what you know in each. What do these letters represent on the top? You got Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Hopefully you knew that. All right, the time of the day can be shown on a clock. Can be either a digital or analog. Ooh, so we're going to read some. This is going to be easy for you guys, I'm sure. So we're reading some clocks. Notice here we have two clocks right next to each other that say the same thing. See, the small hand is in between the 1 and the 2, and the minute hand is right here on, which would be 45, because each one of these is 5, 10, 15, 20, 30, 35, 40, 45. So that's how you get, that's how you read an analog clock. It's really easy, actually. I know some people are afraid of it, especially kids. I don't know why. What's the time that is shown on this clock? And the clock shows 5 minutes after the 9th hour, which means it's 9:05, because you see the hour hand is shorter, it's by the 9. To find the time 2 hours earlier, we would count back 2 hours to 7:05. So we just move this back 1, 2, and it would be on the 7. That's what they're talking about. It's pretty easy stuff. All right, erase my marks. Okay. It is important to make sure that you understand how time passes, because this is easy to get it mixed up, especially when you're counting with an analog. It's also, I know we covered it a little bit in Go Math too. So this is good to review it again. All right. So moving on, we'll start with the practice now. And since this is an even one, we will, I think we'll do this though. I'm going to have you do 1 to 3 because those are so important. I'm going to do 1 and 3 with you and let you do 2 on your own. Hopefully you get it. Remember here it says write an equation. This is the important stuff in this one. This is where you're learning your algebra. So number 1, I'll move it over here to the side a little bit so I can see. All right. Okay. After Anastasia paid Beatrice $600, so this is my important interest here, and of interest, or these are my important numbers. So this is 600 for rent. She had this much left. How much money did Anastasia left? So we had some money. We have 600. Oh, we had some money. We don't know what it is. So let's just say S for some money. And let's stick it right. We had some money, we'll put it up there, and some money went away, or an amount went away, which is this 600 here. And then what we had left was this other amount right here, 7621. And make sure we use dollar signs. So we have some money, we're going to use an S. Here's my equation. It could be S minus 600 would be an appropriate way to write it as well. And then we would figure it out. In algebra, we would do this. We would add 600 to this side, which would get rid of these 600s, because minus 600 plus 600 is 600. And if I add 600 to this side, I have to add it to this side. And voila, there you go. Once you work that out, you bring your S down, S equals, and then, whatever that equals. And there it is. All right, terrible, I didn't do the math for you, but I know you can do it. It's really easy. Remember, 7 plus 0 equals 7, and 6 plus 0 equals 6, and etc., etc. Okay, number 3. And this one they want us to explain. Notice all of the things. We're formulating, and now we're explaining and formulating. Dan separated 52 cards. So we've got one number here, 52 cards, into 4 equal piles. How many cards were in each pile? So if I have 52 and I put them in 4 equal piles, that means I'm going to, I'm separating 4 equal piles. That means I'm going to have 4 piles of something. I'm dividing them into 4 is going to equal some number of cards. That would be the easiest way to write that. Then what I'm going to do to solve it is just, 52 divided by 4. Pretty easy. All right, number 4, because this isn't even. So 1 to 3 and 4 to 30 evens. Here we go. 1/2 of a decade is how many years? And this, you're going to have to go back to the beginning, and I am not going to give you the answer. It's in the beginning. If you didn't watch the video, go back to the beginning. It's example number 1. All right. And then we're going to go to the next page. And let's see, 6, number 6. Okay, this is just a division problem. A fraction is the same thing as division. And if you notice, this is an improper fraction because the number on top is bigger than the number on the bottom, so it's improper. It ends in a 3. That doesn't guarantee that 3 is going to go into it equally. The rule would be if I add all 3 numbers together, I would get, if it's divisible by 3, then it is. So 5 plus 4 is 9. Well, yeah, there it is. And 9 is divisible by 3, and 3 is divisible by 3. So if I add 3 to 9, it's still divisible by 3, which is 12. So there will be no remainders. Yay. So this is a good time to set up long division. All right, so I'm going to put it over here on the side. You can watch it. I've got 3 goes here. I got my line and this 5, 4, 3. First thing I'm going to do is divide 5 by 3. I can do it one time. 1 times 3 is 3. Draw my line, subtract. 5 minus 3 is 2. Bring down the 4. 3 goes into 24 8 times. 8 times 3 is 24. When I subtract, it gives me a 0. I bring down the 3. 3 goes into 3 one time. So, number 6 is 181. And I'm drawing a square around it, so I'm indicating that that's what my answer is. When you do number 8, remember you have to follow the rules of PEMDAS. Remember, we've got these grouping symbols right here and right here called parentheses. And when we remember please, P, which means parentheses or grouping symbols, excuse my dear Aunt Sally. So I have to do these 2 things first, parentheses and exponents, then I can do multiplication and division, then I can do addition and subtraction. In this thing I have no addition and subtraction, so I'm not going to worry about addition and subtraction. I do, however, have a parentheses. So order of operations on this problem here is multiplication, or no, parentheses, then and then division. So 28 divided by 7 is the first thing I do, and 7 times what is 28? It's really easy to figure that one out. And then I'm going to have to work, oh, this is good. This is going to take it in your head. So let's move this over here and I will work it out with you. So we got 28 divided by 7 is 4. So, oh, that's not too bad, is it? 4. And then, once I know that this equals 4, I'll just write it there, that I'm going to do out my long division now. 4 divides into 528. How many times? And you do the exact same thing I did on 6. First thing I do is 4 divides into 5. Once. How many times? Not 5. Once. 1 times 4 is 4. Do my line, subtract 1, and I will let you finish it. 10. Make sure we read all of the directions. It is evening. What time is shown by the clock? It is evening. Here's our first clue. So is evening AM or PM? So choose that when you put down the time. What is the time shown on the clock? We're over here. We look at the shorthand. This is our hour. So our hour says it says, oh, I'm just writing down that it's an hour. And then this is our minutes. And if I count from 12, 12 is where 0 is. 1, 2, 3, 4, 5. Okay, so we should be able to figure that out. What's this out? What is the time shown on the clock? So I have, it's just past 9, 5 minutes. So I'm going to write down 9:05. What will the time be in 3 hours? So I'm going to move this up. 1, 2, 3. This is a trick question. Is it 12:05 a.m. or is it 12:05 p.m.? All right, I'll let you figure that one out. How much money is 1/2 of a dollar plus 5/10 of a dollar? Oh, this is good stuff. I love it. What is 1/2 of a dollar? This is really good fraction stuff for you guys. So 1/2 of a dollar is 50 cents. And then 5/10 of a dollar. Isn't that the same as 1/2? Because 0.5 is the same as 1/10. So if I add 2 halves together, I would get $1. Right? All right. There's a freebie. That one was so easy. Okay. 14. This is easy too, I bet. What is the largest 3-digit even number that has the digits 5, 6, and 7? The largest 3-digit even. So that means it has to end in one number. It has to end in 6. So it has to end in 6. So that's the last number. Would I use a 5 first or a 7 to make the number bigger? It can only be one number with those choices. I'm going to let you fix that. Okay. These are, oh, it's too bad you're not doing 15. That's a good addition problem. This one's subtracting. Looks like there's some regrouping because 8 is bigger than 5, so I have to regroup. I'm going to have a 6 here, and that gives me 15 there. So 15, I'm zooming in so we can read it here. Okay, 15, 8 minus 8. Now we have 7. Uh-oh, 6 is smaller than 8, so I have to borrow again. This gives me a 2 here, and that's 16. 16 minus 8. All right, 8. And then I have my decimal. I'm bringing that down. You have to keep that aligned. Uh-oh, 2 is smaller than 6. I have to borrow again. I make that 5, and now I have 12. Half of 12 is 6, or 6 minus 12 is 6. 5 minus 4 is 1. And then notice there's this cool thing here called a $sign. If I don't put that down here, I actually don't have that number right. So make sure you put in your dollar signs if it's a $sign. All right, multiplication. This is simple. Also, again, simple. You're just doing simple multiplication here. 9 times 7 is 63. Oh, I did that wrong, didn't I? Okay, so let's go back and fix that. 9 times 7 is 63. Carry my 6. 9 times 8 is 72. 72 plus 6 is 78. Put your 8 here. Carry your 7. I'll let you finish it. 22. Write 2 multiplication facts and 2 division facts for the fact family 10, 2, and 20. This is so good. I know some of you are going to be lost. So here we go. I'm going to hold 10 times 2 equals 20. Correct? And 2 times 10 equals 20. 20 divides by 2 equals 10. And I think you can get the last one. All right. 24. What are the next 3 terms in this counting sequence? Look at that. It's going 5, 400, 500, 600, 700. The one before would be 300. All right. I think you can get that. Now, 26. Which multiplication fact shows the number of small squares in this rectangle? This is pretty simple. So I've got 1, 2, 3, 4. That means I got 4 on this side, and 1, 2, 3, 4, 5, 6, 7 on this side. 4 times 7. Oh, so I have 4 times, I'm using a dot instead of a X because that's where it goes. 4 times 7 equals, and what should I say? Which multiplication fact? 4 times 7 equals, and we need to have the total number inside. It should be 28. So it could be that, or it could be 7 times 4. It doesn't matter. Wow, we've got to do 27. Here it is. How many centuries equal a millennium? Remember at the beginning it says how many centuries are and what of them, how many of them equal a millennium? A century and millennium. So I know you can figure that. How many quarter circles equal a whole circle? Oh, these are great questions. So if I draw a circle, this is what you would do on your work. To show your work, I have a circle. If I divide it into 4 parts, how many? 1, 2, 3, 4. There you go. How many quarters make a whole? 4 quarters equals 1. Easy, huh? Okay, 29. How many minutes are in an hour? How many minutes are in a half hour? And use the number in the answer to part A and B to write a fraction equal to 1/2. All right, here we go. How many minutes are in an hour? Just go back to the beginning of the lesson that shows you up in example 1 or 2. And same thing here. How many minutes are in half an hour? So this may be a review from 23, but if there's... Anyways, I think you can figure this one out. I'm not going to do it. And then they're going to want you to write a fraction equal to 1/2. So if you didn't notice here, half an hour and then an hour. So they use the word half here and equal to 1/2. So if you write down how many minutes are in a half of an hour and over the whole, that's just a fraction. Half over the whole. 1/2 hour over 1 whole hour. Anyways. Multiple choice. During their retirement, Tanisha's grandparents plan to visit every state in the United States except for Alaska and Hawaii. So far, they have visited 29 of those states. Which equation can be used to find how many states Tanisha's grandparents still have to visit? So, they're going to visit every state in the United States except for Alaska and Hawaii. So, if they're taking out this state and this state, that means they're only going to visit how many states? 48, right? Because there are 50. So, it can't be this one, because that one has a 50. It could be, what other one could it be? Oh, and they've done 29. So, let's see, 29 plus a number equals 48. Or would it be 29 plus 48? Oh, it can't be that one. So it's not this one. It's not this one. All right, let's see. If you haven't got it yet, you should get it pretty quick, I would guess, huh? 29 plus n. Could it be this one? N plus this one. So then this would be, they're only going to visit this many, right? So can it be this one? No, it can't be that one, can it? So we're left with C. All right. That is your lesson.